Welcome, everyone. I know it's always a challenge, last day of the summit, late in the afternoon, so appreciate your attendance for sure. My name is Brent Biddulph. I lead the retail and consumer goods group at Cloudera, and this is my colleague and partner, Florian Mullerklein, data scientist from Miner and Cash. So what we wanted to cover in this talk was just a brief overview of the retail industry in relation to computer vision, and while it's nascent, how it's growing, and how it's attached to business drivers and business impact. It's having great influence. Provide you with some example use cases, and then Florian will cover how it works in general, and then bringing it all together as the close. So 86% of retail sales still occur in-store. So why are we talking about computer vision in-store? This is the primary reason. Yes, computer vision is used quite extensively on digital or pure play online retail with image search, et cetera, but in-store retail is really starting to pick up with new technologies and leveraging new data sets in the space of computer vision. So if we think about the new data sources that are emerging based on new technologies that are being deployed, you can call it IoT for the most part, and it isn't just reserved for industrial usage or manufacturing. Retailers have had IoT for several decades, primarily in the sensor space, and then they've been adding beacons. There's satellite images that are now being used in the industry. Magic mirrors, if you're familiar with that concept, typically in the apparel segment. Competitive price scraping, to be able to pull in information digitally from competitive prices, electronic shelf labels. We're seeing robots. I've got an example of how robots are being deployed in store as well. Autonomous vehicles. There's a lot of testing going on with retailers now for delivery purposes and fulfillment of products, as well as shelf, bin, and rack sensors to be able to understand product movement, out of stocks, replacement alerts for in-store activities as well. So just to define computer vision at the highest level, essentially, it's a subset of AI, of course, and basically it's about dealing with digital images or video. So this is a level set. So the key retail business imperatives that computer vision is solving for today really are enabling frictionless commerce, improving operational efficiencies, improving customer experiences, and reducing fraud and shrink. These are all key pillars within the industry. The computer vision is now helping retailers to evolve their capabilities, provide new metrics, extend business value to key challenges within the industry. All of these are promising areas for computer vision, and several are being deployed and tested today. Some are even being rolled out from pilot to full production across the entire chain. 50% of digital shoppers are inspired to purchase via an image. So as consumers, we're already used to being inspired by a product and then trying to match it. Actually, Florian will use that as an example today. $800 billion in AI and IoT economic value is expected by 2025 in retail. A good chunk of that will be driven by computer vision. So negative 5% applies both to lost revenues due to out of stocks as well as fraud that occurs in retail. Now, for apparel retailers, they can absorb that because their margins are a little larger, but for fast-moving consumable goods companies, that's a big hit. Comes right off the bottom line when you're talking about segments of the industry that net profits run about 2%. So it has huge implications that computer vision can help to address. And the out-of-stock issue, which has been a perpetual issue, primarily in fast-moving consumable goods, traditional retailers are now starting to understand that when they're out of stock of a product, of course, it's a big hit. You got a lost sale, you got a bad customer experience. But now, recent research now indicates that as the consumer can't find that one product within the store, not only are they frustrated, as they're walking out the door, they're just ordering on Amazon and having it delivered to their home versus picking it up again on a future trip. And that contribution is about 25% or 24% of Amazon revenue can be contributed to out of stocks in traditional retail. It's a pretty big number. So we want to talk about enabling frictionless commerce. I don't know if you all are familiar with the Amazon Go store in Seattle. They've now rolled it out to several other markets. So this store effectively You take your mobile device, you log into your Prime account, you scan a QR code on your mobile device, you walk in the store, you pick up your goods, and you walk out. There are no cashiers. So this has been tested for a couple of years at Amazon, 1 year with their employees, and then they rolled it out to the public the end of last year. They're continuing to extend this market by market, and effectively the entire store is run by computer vision, sensor fusion, and obviously deep learning algorithms. Now, the footprint's about 1,800 square feet, so it's not a giant store. The products are very well curated to be able to, capture movement of products off the shelf and as the consumer's walking out the door. But it's moved beyond an experiment now to a public offering, and you're able to go into any of these stores and shop it yourself as long as you have a Prime account. Another example is Alibaba's Hema store. So in China, the cultural differences there in terms of facial recognition are a little more accepted, as is cashless payment. So Alibaba has started to roll out their Hema store concept, which really kind of brings online and offline together. And here they have robots that are basically, you pick out fresh seafood, you can actually have it prepared and delivered to you tableside via a robot that's cruising up and down tables, kind of like you'd see in some of the sushi bars. They also have overhead conveyor belts for pickup and delivery, so they're picking from these stores, pushing it through conveyor belts to the back door, and then basically shipping it out. But the most interesting thing, or at least used from a computer vision standpoint, is the fact that you can check out with your face. You don't need your phone. They don't use cash anyway, so you've accepted an imprint of your face as a consumer. Now, this may not happen in the West, but in China, it's very well accepted, and they have pretty good penetration at several of these stores in terms of just checking out with your face, so you don't even have to use a mobile device. This is probably the business case in retail, especially in fast-moving consumable goods, that has a huge ROI opportunity. This is in tests in virtually all of the large grocery chains, and it's the idea of a robot mounted with cameras cruising up and down aisles. This robot can cover a store 3 times a day. It can cover a 45-foot aisle in about 60 seconds on both sides. And so the purpose of collecting this information is, one, to make sure that our merchandising is in compliance. So make sure that the pricing is correct, the promotions or the tags on the shelves are correct, and probably most importantly, where there are out of stocks. So understanding where a product is out of stock, being able to alert the in-store employee that, hey, we've got an issue, you need to restock the shelves, and being able to provide that all in real time. The other side of this equation is the monetization of this data. A lot of the large CPG partners that provide these products or that are purchased by the retailers for sale, they pay hundreds, if not millions of dollars for this type of information from third-party syndicated providers like IRI Nielsen, Catalina, others. And typically it's a 30 to 45 day after the fact, and typically it's sample data, it's not individual store data. So now the retailers have the opportunity to monetize that data with their supply chain partners, or back to the third party to provide them more granular level of detail to sustain the model. So the opportunity to monetize the data externally is quite large in this area. Another aspect, so if a retailer doesn't want to go to the expense of the mobile robots, electronic shelf labels now are being created with cameras built in. So if you think about the 2 sides of the aisles with cameras pointing in both directions, you can effectively accomplish the same thing as a mobile robot in terms of capturing images and information from both sides of the aisle. Oops. So moving from operational efficiencies to improving customer experiences. So this is very much nascent in terms of testing, and not a lot of retailers like to talk about this, but effectively using ceiling-mounted cameras pointed at the front doors of their operations, especially for mass merchants, to be able to not necessarily know the person individually, but from an anonymous level, understand facial expressions and moods. And why are they doing that? Well, they're doing that because a lot of these stores are such huge sizes. They have customer service desks and people behind the customer service desks that really never get out or interact with customers. This is providing a brand new opportunity in retail to be proactive when they see that a customer walking through the door may be unhappy, maybe a mother with a bunch of kids hanging on her, trying to get off on her journey. To be able to identify those opportunities of engagement is a customer experience opportunity within brick and mortar. And then the magic mirror, this has been out for a while on Neiman Marcus. Several of the retailers have used this. You also see it at Sephora and beauty counters. But the opportunity to improve and simplify the dressing room experience, so not having to change a bunch of times, be able to put on a style, pick your color, and then ultimately swipe different styles, patterns, colors of a dress, of a blouse, whatever the outfit is, a suit. And then also have the opportunity here to upsell. So be able to complete the look in terms of complementary products, to be able to provide recommendations in terms of shoes or accessories, et cetera. This really eliminates a lot of time and hassle, typically when going shopping for clothing. So this is still, I would say, experimental, but in high-end fashion, it tends to take hold a little bit better than it would typically at a mass retailer. So those are some examples that tie to direct business impact and value in terms of how retailers are leveraging new technologies. Other areas, just some examples, beyond the frictionless entire footprint of a store, there are actually frictionless carts. So scales built in, cameras built in, checkout on the handle, so you can, so for larger locations, the Amazon Go store is basically a convenience store. So if you think about a larger footprint where you're going to be gathering more products, this could be something that could be more applicable. Another area in terms of customer insights and using cameras typically built into the ceilings is now starting to move from just understanding gestures in terms of coming in the front door, but also on the shelf. So understanding the association of the product. If you're picking it up, what you're looking at, if you're putting it back or putting it in your cart, this is essentially what's going on in the Amazon Go store in terms of the gestures that are occurring. Also with video, you can start to understand customer engagement, so you can distinguish between customers and staff. So if you think about an electronics retailer, they may want to know, are my associates engaging with customers as they're browsing? And if they are, is that ultimately leading to a conversion? And then you've probably all seen the heat maps. So if you think about digital capabilities now brought down into the store, you can start to understand purchase paths, dwell time, conversion, engagement. Those are all new measurements that are brand new for retail, at least from a brick and mortar standpoint, which are pretty exciting. And there's a lot of application and testing going on here as I speak with retailers around the world. And of course, loss prevention. This is a little bit of a sensitive area. There are applications that have been out there where they'll actually have the mugshot of the individual and they'll truly apply facial recognition, understand if that individual's in the store. No retailer really wants to talk about the use of that, and they're very careful, especially in the West, of using that. I don't see widespread adoption of that just because of the sensitivity from a cultural standpoint. But it is something that certainly can alert activities, again, even if you're just using gesture information in terms of typical behaviors. I've seen one application of this at one retailer actually in North America that's basically ingesting the POS data at self-scan as well as cameras in the ceilings and understanding if consumers turning a product over with the UPC facing up, pretending like they're scanning, especially lightweight items that the scale's not going to measure, like cosmetics or light, high-ticket type items. And there's a lot of fraud activity that goes on there. So if you're able to pull in and do sensor fusion with video, you understand the gesture, there's no scan on the POS, you've got a central cashier there that can go interact with the consumer and ask them if they're having any issues scanning that particular product. I actually saw this at Shop Talk. I was unaware of this capability going on out there, but there are providers out there that are providing satellite imagery to retailers to understand number of cars in parking lots, not only in theirs, but competitors, to start to understand traffic around physical brick and mortar locations, and then starting to apply metrics to that based on year over year, time of day, et cetera, to start to understand what kind of conversion are we getting from parking lot to store versus our competitor and what's going on. This cart down on the bottom, I guess it's the bottom right, autonomous driving. So our friends at Ahold are actually testing with Peapod on the east coast of the U.S. automated delivery or autonomous driving vehicles, and this particular one is another test where they're actually not just autonomous delivery, but autonomous store, where you actually are able to then pick products, purchase without an individual there on location. And then the middle one is really applied more towards digital, but this really gets to the apparel side of retail as well, and moving from sizes to fit. And we see this with Stitch Fix and others, right, that are taking arm measurements all the way through the body to really get a more precise fit for products. So apparel retailers are starting to move more towards fit using computer vision versus just general sizes. So with that, I'll hand it off to Florian, and we'll get a little bit more into the data science behind this type of activity.
Cool. All right. Thanks. Yeah. So I'm going to talk about how this works. So as a data scientist, I build a lot of these tools. So what I wanted to do is kind of give a quick high-level sort of how these things are working under the hood and how I think about the problems to help you all sort of decide for yourselves if you have a problem where this could be applicable, and how to go about thinking through these problems and creating something similar to this. What I'm going to show later is a sort of a demo that's going to be akin to the magic mirror type use case. So what we're going to do is we're going to take an image of somebody. We're going to say, we really like the look of this article of clothing. Can you find me the most similar article of clothing in your store that looks like the one that I'm seeing, right? So if this is a magic mirror situation, maybe you tried something on, you really like it, and you want to find more things like that. And you can do that search in a semantic way rather than a sort of kind of structured inventory way. And when I say semantics with images, what I mean is, what are the sort of patterns and characteristics of that article of clothing? We can actually train a deep learning model to sort of recognize those patterns. So like in the diagram here, what we'll do is we'll detect an image. We'll sort of segment it into its various components. We'll search through our catalog, which is represented in the middle here. So this image in the middle is actually the learned sort of semantic space coming out of a neural network, and it's kind of automatically learned how to sort of sort an inventory based off of the visual attributes of articles of clothing. And then what we'll do is then we'll match, the best match for the piece of clothing that we're looking for. So just as a quick high level, so deep learning is sort of eating computer vision these days, right? So essentially what it is, it's a multi-stage machine learning model, right? Whereas each stage is making some kind of high-level representation of the data that kind of facilitates new use of your data that you may not have previously had. So when I think about a deep learning model, I sort of think about it as three stages. I think about the input, the big middle part, which is actually the deep part for, that's where deep learning comes from. That's the representation learning section. And then the final part is the output. So we could train that output to do something direct. For whether you are doing like autonomous driving or something, that could be like whether to accelerate or steer, or if you're trying to say if a shelf is empty, it could directly tell you that shelf is empty. But what you could do as well is sort of dig into the middle representations and actually facilitate new uses that the model was not directly trained for. And we'll do both of these things, in the demo. So what we call those representations, or we call them sort of latent representations, right? So it's this sort of mathematical space that the neural network sort of designs based off of the data that it's seen so far. We'll use that to sort of, facilitate new uses that were not directly trained by the network. The example that we'll do is like semantic reverse image search, right? So if you know reverse image search from Google, where you sort of like give it an image and you say, tell me, find me similar images of this. That's a bit more direct, like it's trying to, match the image more directly. But what we're going to do is we're going to say, find me things that are either complementary or similar to this item, right? And so, for the fashion use case that we're sort of focused on here, that's going to be really, really useful. All right, so we went over this a little bit, but all of these sort of computer vision use cases and things that were brought up, a lot of those are going to be powered by neural networks, right? And so like I've been saying so far, you can have a neural network directly output something you want, or you could use the intermediate layers, and all of those things are using the same underlying models. So it's all sort of one kind of homogeneous system. It's just how you process the output will vary. All right, so we'll run through the demo. Just a quick disclaimer about the demo. So I was sort of limited to the public data that was available. So there is no like magic mirror public data set, right? So the images will look a little more sort of staged and like professional because that's the public data that was out there. What we're going to do is we're going to say we want to find a coat. We select the image in the bottom left to say, that's our favorite coat out of here, and then we're going to have the neural network search for the best match. So I did run this on a laptop, so it's a little bit slower than it would be, if you actually put this in production. But it's going to think for a little bit, and then what we'll see down here is the extracted coat from the first image, and then it's going to sort of dig through our inventory in our catalog and sort of give us the best match to the coat that we were looking for, right? There's two things at work here. So, first, the model is directly labeling every single pixel in this source image as to say, this is a pixel that is, for the jeans. This is a pixel that's for the coat. This is a pixel that's for the handbag. And then what we do is we take out the ones that we're actually looking for, and then we run a similarity search over that. And then this image at the top represents an image that is in our catalog. So here, I sort of designed a fake catalog based off of all the images that I could find online. And this is the sort of space that the network has learned how to organize the images in our catalog, right? So, this could be any type of product that you have that has some sort of like semantic design component to it, right? So if we go through the space, we'll sort of start out here, and I like to call that the flannel island. So it's kind of taken all of the flannel shirts and stuck them together. Over here is like hoodies and jackets and things like that. And if we go down, we get like other kinds of jackets and blazers and things. And then the last sort of section that we'll look at are the jeans and pants and all of that. So, this model wasn't specifically trained to, sort of segment out all of the various different patterns and things in clothing. It was only trained to segment out clothing into its like highest level category, right? So whether that's pants or jackets or T-shirts or things like that, that's all it was trained on. All of this sort of like pattern similarity and all of that type of thing, it's learned on its own through the process of, just dividing everything up into its sort of big category bucket. So, we'll dig through the sort of demo here and go into exactly what was going on. So, creating this recommendation system, we can break it down into a few components. So, like I said, first we need to extract each component that we're looking for from the source image, right? So, whether that's some professional photograph like I showed here, or whether that's a camera in your store, or maybe somebody actually is like bringing in a photograph and they're saying, I like these types of things. Can you show me things in your store that look like that, right? So whatever the source photograph is, we need some way to kind of pull out the sort of discrete components of that image, right? And then once we have those discrete components, we need to create some semantic representations that we can search through in an efficient way. And then finally, we're going to do like a comparison on the sort of source component with everything in our inventory, and then we need to sort all of the matches afterwards. So here, the first thing I did is I trained a neural network to just simply segment an image, right? So it'll take any one of these, photographs, and it'll segment out into its various components, right? So it tells me the sunglasses, the hair, the skin, the handbag, the dress, and the coat. From this image. So then what we do is then we apply a filter based off of what we're looking for. So when we typed coat into that search box, that was essentially applying this filter, right? So we'll just say, well, you want 1 for whatever we're looking for and 0 for everything else. We apply that to our image, and then we get the extracted item out of that, right? So that could be any one of those segmented objects from the left pane here. And then what we do is we then pass that through another neural network that was sort of designed to help us fit all of these products into their category. That gives us a sort of numerical representation of all of the qualities of that image, right? And then what we can use that now, that numerical representation is now the new sort of, stand-in data point for that extracted image, right? Then we do a simple calculation here from our vector representing our image and every single vector in our category, or maybe some filtered vector for every single thing in some category in our catalog, right? We perform this calculation, and that gives us the best match. So in this case, we have an original image, we extracted what we're looking for, and then we returned a match. So that's just a quick high level of a specific example that we sort of threw together for this. But again, all of the use cases that we sort of covered were powered by neural networks and deep learning, and all of these sort of techniques are in there in some capacity. So tying it all together, we can have a streaming ingest or batch ingest. So that would be akin to if we have a video, taking the feed in, and we're sort of parsing the images from the video and acquiring the relevant sort of specifics from that image. Or we can do a batch, if this is something that you want to sort of process in the back end, right? So if it's not a real-time situation. So here, the data engineering for images, as long as we can keep them organized and pipe them to the neural network, we're pretty happy there. So the machine learning aspect then would be the neural network that's going to sort of crunch on that image in whichever way that you're looking to do that. We can warehouse all of the outputs from the network, or we can just sort of push out the output directly to the user, like we did in our example, right? So that essentially covers it.
Yeah, fantastic. And if anyone has any questions, we were reminded to please use the microphone in the center of the room.
That's right. Yeah.
Certainly, if anyone has any questions.
Thank you for the talk. That's really interesting. So I'm curious, is this already in production? Any kind of real-time retail analytics in store using CCTV, or just like a prototype which are trying to evolve and develop?
Sure. I can give one answer. The example that I mentioned with the self-scan checkout and the video cameras above and the sensor fusion that's occurring there, that was in a pilot at a very large retailer. I think they piloted about 100 locations, and they are now in full that was a whole year of testing, and now that's on a ramp out to thousands of locations. That's one example. The Magic Mirror actually has been out there in test, at least in North America, for several years. But what we're seeing is moving even that technology to mobile devices, so you can even do that from a catalog and do that stylistic, at least from the fit standpoint, that's deployed already today. Some of the others, like recognizing moods of customers, that's very much in test, several, but has not been fully deployed. The Amazon Go concept, obviously that's deployed, but there are now, since that has been deployed, there's a lot of solution providers that basically have knocked off that capability, and now they're taking it to market. I've yet to see any retailer outside of Amazon actually roll that out beyond what Alibaba is obviously doing, which is in some cases even more sophisticated. But yeah, it's likely that in some way, shape, or another, everyone in this room has been in a retail location where computer vision is being used in one way or another. One of the exciting things, actually, that it adds value to are the electronic shelf labels. Those have been out in the industry for decades. The barrier was cost, and then return on that investment. Now what's occurring is they're becoming obviously more capable to even offer pick and pack information loaded with video camera. Now you can start to do the merchandising compliance. Those are very much in test, and recent announcements indicate those are going to be rolled out chain-wide, at least at a couple retailers here within the next year. So,
Thank you.
yeah.
Flora, probably a question to you. So, from your experience, whenever it works better for you, when you train a model and build model, especially for your like specific needs, or you just transfer learning from one existing architecture?
Yeah. So I've done both, and yeah. So okay. The times where it becomes the most critical to design your own, I found to be when the latency was really critical. This would be, so a specific case would we had really high resolution images, and we needed something that could run really fast. And so no existing architecture was fast enough to sort of, produce the output we were looking for on an image of that resolution. So we actually had to sort of design our own architecture that was a bit quicker to push an output there. However, most of the time transfer learning will work perfectly. For the demo here, it was all done with transfer learning, with a couple of clever modifications to clean up some of the output, right? Yeah.
Thank you.
Sure. Yeah.
Anyone else? Oh, good. He's going to use the mic. The guy back there will be happy.
I'll listen to instructions. Any kind of computer vision stuff is going to, in this part of the world, involve privacy issues,
Yeah.
especially in stores. I was wondering if you have any advice on how you can push something like this through legal obstacles.
Yeah. So I'm not 100% on all of the requirements in GDPR, but if you could certainly train a very capable model on just public data and not store anything. So you could do the inference on the edge and not store anything. If you were looking to do training on the images that you're capturing, one of the previous talks today about federated learning might be very, very helpful there. However, just because a model has trained does not make all of the data that is previously, it doesn't mean that data is now erased. There are sort of adversarial attacks and things you can do to a model to sort of probe it and get some of the training data back.
Yeah. Also, often they want to have the data anyway to do reinforcement learning to catch the false positives and make the model better, so that they kind of want to keep the images anyway.
Yeah. It's a tricky situation.
And it's also very sensitive in North America as well, and this is why the whole fraud scenario of facial recognition really kind of got washed away. But the other thing with computer vision, frankly, the majority, the business value is not coming from people, it's coming from products, right? Understanding stocking conditions, understanding merchandising compliance, understanding, outfits and publicly available information. So there's an equal balance. It isn't all about the facial component, if you will. Also, even the loss prevention scenario, you don't see the person's face, right? You just see the gestures. So again, no violation of privacy there.
Any other questions?
Anyone else?
All right.
All right.
Thanks
Thanks
everybody.
everyone. Appreciate it.